Welcome back, everyone. So for this lesson, we're going to be talking about polar coordinates and how we're going to kind of transition into those from our rectangular coordinates. So starting off, we have our drawing that we did from when we first learned the unit circle. And this is just kind of our graphic and our information from when we're solving for sine, cosine, tangent, and the actual radius. So all this should be kind of a recap, but we're going to use this information as we segue into our new type of graphing. So with polar coordinates, this is going to be a new type of graphing system. So we're used to graphing in what we call the Cartesian or the rectangular coordinates. Well, so it's a Cartesian coordinate grid, but they're called rectangular coordinates. So that's what we're used to graphing, but now we're going to go from our coordinates our coordinates x, y, and we're going to transition into points, or coordinates rather, that are going to be in the form of r, theta, where your r value is going to be your quote-unquote radius, but it's actually going to be a distance. And then your theta value is going to be your angle, which is in standard position, or it may not be in standard position depending on the context of the problem. So when you're graphing in polar, just like the context of an origin being the center of your graph, we're also going to have the center of a polar graph, and we call that the pole. The pole is going to be equivalent to the origin, but for polar. And then your r value is going to represent the distance you move from the pole, whereas theta is going to be the angle where you move from the graph to a specified point. And then for your theta value, back when we first learned about the unit circle, the context of it being positive or negative and then clockwise or counterclockwise, all that information is still going to hold as well. And then you may have to find what we call a coterminal angle, which once again, this should be a review, depending on what type of angle that we give you. So just kind of diving right in. So your polar graphs are going to look like these concentric circles. It's almost going to look like a dartboard or even like a target. The middle, right here, smack dab in the middle, this is going to be your pole, which is going to be the equivalent of like your origin. Now, if you look around, you're going to see all these different spokes, which kind of come from the pole. Now, if you count the number of spokes that we have, there's actually going to be about 24 in total if you go all the way around and then back to the very original spot, or the starting spot. So I know that from the unit circle, if I start in standard position, this is going to be where we start. And if I know that we're going to start here at 0, and I know over here is going to be pi, and we come all the way back to 2 pi, but then there's 24, that means my scale, I'm actually going to count by pi over 12. So that means this first spoke would be pi over 12. And then the next one would be 2 pi over 12, which is actually going to end up being pi over 6. And then the next spoke, which would be 3 pi over 12, which is going to be pi over 4. And then we're going to have pi over 3. And then next we're going to have 5 pi over 12. And then 6 pi over 12, which is equivalent to pi over 2. Then 7 pi over 12. And then we're going to have 8 pi over 12, which is 2 pi over 3. Then 9 pi over 12, which is going to be 3 pi over 4. Then we're going to have 5 pi over 6. And then we're going to have 11 pi over 12. Sorry, y'all, counting is hard. My brain has to buffer for a second. And then over here, when we get to pi, this would be 12 pi over 12, which is just pi, so I don't need that. And then 13 pi over 12. Then 7 pi over 6. 5 pi over 4. 4 pi over 3. 17 pi over 12. 3 pi over 2. Then 19 pi over 12. 5 pi over 3. And then we're going to go up to 7 pi over 4. 11 pi over 6. And 23 pi over 12. And then all the way back to 24 pi over 12, which would just be 2 pi. So we won't need that one. So this is going to be kind of your graph that we're going to be referencing. So starting off, I want to plot the point 5 comma pi over 3. So what this tells me is I want to go to the fifth circle from the pole in the direction of pi over 3. So I want to go in the direction of pi over 3. So what I'm going to do, if it helps, you can highlight the line that we want to be on. So from the pole, I want to go in the direction of pi over 3. So I need to be somewhere on that line. And then I want to go to the 5th circle from the pole. So counting from the middle, so starting here at the pole, then we're going to go 1, 2, 3, 4, 5. So right here, this would be our point. And then when you draw your point, you need to make sure that you label your point. Because on your assessments, we could potentially give you multiple points to put on the same graph. So you are going to be required to label your points just in case. Now, just future reference, as you can see, none of these graphs are labeled. So you are going to be expected to remember the sequence as you go around. So hopefully what you notice is that it's just the unit circle, but we add in a few more values. So the values we add in the pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and the 23 pi over 12. So it's just the unit circle, but a few more values added on. So now I'm actually going to jump over to number 7. Not number 7, hello. Number 3, which has 7. So with number 3, we want to plot the point 7 comma negative 2 pi over 3. So because of this negative angle right here, instead of going counterclockwise, now we're actually going to go clockwise from standard position. So negative 2 pi over 3, this is actually the same as just going to 4 pi over 3. So that, in regards to placement, put you right on this line right here. And then we want to go to the 7th circle. So if you look at this circle that's a little bit darker than the others right here, this is actually going to be 5. And then the very outer circle right here that's also dark is going to be 10. So those dark circles are going to be by a scale of 5, if that helps. So whenever I see that, I know I'm actually going to start here at 5 and then 6, 7. So this would be 7, comma, and I'm going to label it based on the original angle. So I'm still going to write negative 2 pi over 3. But if it helps, you can graph based on the positive angle. Now I'm going to come over here to number 4. I'm going to jump around and then we'll come back to 2 and 5. So now we have 13 halves, comma, 13 pi over 4. So 13 halves is going to be between 6 and 7. So it's 6.5 more specifically, but in case you get any weird values, you can at least try to find like what numbers it's between. And then 13 pi over 4, well, this is bigger than 2 pi, so what that tells me is I need to find a coterminal. So with 13 pi over 4, what I'm going to do is I'm going to subtract 2 pi. So we're going to have 13 pi over 4, and then I'm going to subtract 2 pi, but I'm going to rewrite it as 8 pi over 4, which is going to give me 5 pi over 4. So I know I need to go in the direction of 5 pi over 4, which is going to put me in this direction. So I'm going to go to the 6.5 circle, 6.5 circle, however you say it. So that's going to be between 6 and 7, which means I want to be in between. So I'll get rid of those. And then I can label, so then this would be 13 halves. And then once again, we're going to label based on the original. So 13 pi over 4. Then we're going to go over to 6. So these are my personal faves. So when you look at this value, we're going to go in the direction of 19 pi over 12, which is an absolutely abhorrent and disgusting value, but it is on the circle that we're looking at. But if you look at your R value, notice how the distance from the pole is 0. So when the distance from the pole is 0, that tells you we're just going to be right smack dab in the middle because the distance is 0. So we are at the pole. So it doesn't even matter what the angle is. As long as that R value is 0, you're stuck at the pole. So you just stay there. So now that we did those 4 with either a positive or a 0 R value, now we're going to look at the negative R values. Ding, ding. So with number 2, so we are going to plot negative 4 comma 11 pi over 6. So what's going to happen here is I'm actually going to ignore this negative for a second, and I want to plot 4 comma 11 pi over 6 first. So if I do positive 4 comma 11 pi over 6, 11 pi over 6 is going to put me in this general direction. And then if I go to the 4th circle, that's going to put me right here. So this is going to be positive 4 comma 11 pi over 6. Now what's going to happen is this negative is going to add just one extra step. It just means that we need to go the opposite direction. So opposite direction as in we're going to follow the spoke on that unit circle, and we're just going to go the opposite way. So now instead of going towards 11 pi over 6, now I'm going to kind of go the other way, and we're still going to be 4 circles from the pole, but now that I kind of switch directions, now I can make that r value negative, but we're still going to keep that same angle. So this would be your original coordinate. Now, a couple of good questions I got asked is, do I need to label both the positive and the negative? No, you only need to label the negative one, so you don't have to label this one if you don't want to. But of course, if you do, perfectly fine. I would rather you give me too much information than not enough. So that being said, I'm going to let you guys try number 5. So I'll take like a 2-second break. So with this one, with these, I like to ignore the negative first. So I'm going to graph 3 comma pi over 2. And then because of that negative, it just means I'm going to go the opposite direction. So I need to go the other way. So now I'm actually going to end up down here. So this would be negative 3 comma pi over 2. So once again, you don't have to label the positive one. You just need the negative one, but tomato, tomato. So just make sure you are labeling your points on your circle or on your polar graph, just because we may give you multiple points and you will be required to label all of those points in order to receive full credit. Now, moving on, this is kind of applying what we just did. So we're going to plot the point 6 comma negative 3 pi over 4, and you want to find 3 additional ways to write the same point. Now, keep in mind, we're saying you're going to write the same point. So every different way that we write it is going to represent the same value. So what I'm going to do first is I want to look at the coordinate that they are giving us. So we have positive 6 comma negative 3 pi over 4. So we're given the positive negative value. So that means over here, 6 comma negative 3 pi over 4, this is given to us. So I need to find the other 3. Now, this is what your questions on assessments potentially will look like, as in we'll give you one of the 4, and you have to find the other 3. So when I start plotting, so negative 3 pi over 4 is also going to be the same as 5 pi over 4 in terms of finding a coterminal. So that means I need to be over on this line. But when I am plotting my values, I'm always going to start in, I'm always going to start in standard position. So I'm always going to start on the positive x-axis. This is just how we measure angles. So I know this value here, this is going to be negative 3 pi over 4. And then I want to go to the 6th circle. So I'm going to be over here. So this is going to be 6 comma some theta value. So this is essentially what we're given. Now, if I want to find a positive angle, I can go counterclockwise to find that same value. So if I go all the way around, well, that's going to give me a theta value of 5 pi over 4. So if anything, what you can do is you can always just add 2 pi to that value, the negative 3 pi over 4, to find your positive angle. So that's one way you can do it. I like to just kind of visually look at it and mentally do the 2 pi, but whatever you're most comfortable with. So when I do that, that's going to give me a positive r value and a positive theta value, which means that's going to be put over here. So we're going to have 6 comma 5 pi over 4. So now I have both of the positive r values. Now we need to actually switch. Now we're going to look at the negative r values. So what that means is I'm going to take my little line over here, and then we're going to extend it, but on the other direction. Let's see if I can get the right one. So now I want to go to the 6th circle, and then because I'm flipping it, it would be a negative. So now I want to find both the positive and the negative angle that correlate to that specific point. So if I were to look at my angle here, if I start in standard position and go up, I'm looking for the angle that is across diagonally from 5 pi over 4. So if I think about the unit circle, across from 5 pi over 4, well, that's going to give me pi over 4. So I know this angle right here, if I have a negative r value but a positive angle, so that means I'm going to have negative 6, comma, pi over 4. And then now I want to find a negative angle, so I'm going to go all the way around. So I want to start in standard position, and then go all the way around to find that negative angle. So you can do pi over 4 and then subtract 2 pi if you want to find that coterminal, which that would give you negative 7 pi over 4. So if you want to do it that way, you can. So this would give you negative 6, comma, negative 7 pi over 4. So I will say these types of problems are going to be pretty important. I know your homework has a bunch of different problems like this, so definitely practice those. Moving on. So now we're going to convert between polar and rectangular forms. So this is kind of building on the diagram that we did at the very beginning. So I'm going to let you guys kind of take a minute to write all you need, and then we're going to just dive into some practice problems. So starting off, we're going to convert the following polar coordinates to rectangular coordinates. So if I'm going from polar to rectangular, we're going to focus on this left side over here. So polar to rectangular, what this means that we're going to do is we're going from r theta, and we're going to go to xy. So by doing that, we're taking our cosine and sine values over here, and we're just going to solve them for our r values. Not r values, sorry. We're taking the sine and cosine values, and we're solving for x and y respectively. So my x value and my y value are going to be equal to the r value times either cosine or sine, depending on if we're finding x or y, and then of that specific angle. So with that, we're going to dive into this problem. So I have 4 comma pi over 6. This is a polar graph, or a polar point. Now I want to convert it to rectangular. So what I'm going to do is we're going to do x is equal to the r value times cosine theta, and then the y value is going to equal r times sine theta. Now keep in mind, your r value and your theta value are given to you in this coordinate. So when I plug in, x is going to be equal to 4 times cosine of pi over 6, and then you're going to evaluate cosine pi over 6 from the unit circle. So cosine of pi over 6 is going to be root 3 over 2, which is going to be equal to 2 root 3. So that's your x component. Now we need to find the y component. So I'm going to do 4 sine of pi over 6. So this is going to give you 4 times sine of pi over 6, which is 1/2, which is going to give you just 2. So your coordinate would give you 2 root 3, comma 2. Now with that, I'm going to give you guys time to try 2 and 3. So if you can, go ahead and pause here or fast forward, whichever. So with number 2, so we're going to find our x and y components. So with x, we're going to do 2 times cosine pi. So cosine pi, which is going to give you -1. So 2 times -1, which is -2. And then with my y value, we're going to do 2 sine of pi. So 2 sine of pi is going to give you 2 times 0, which is 0. So my coordinate here is going to be -2, comma 0. All right, number 3. So we've got 10, or -10, sorry, cosine 3 pi over 4. So this is going to give you -10 parentheses, negative root 2 over 2, because we are in quadrant 2, which is going to simplify to positive 5 root 2. And then for my y component, so -10 sine 3 pi over 4, which is going to be -10 times positive root 2 over 2, since we're in quadrant 2, which will give you -5 root 2. So my coordinate here, 5 root 2, comma, -5 root 2. Ta-da! Now the note that I do want to give you guys for number 4 So we do give you a negative angle here. So we give you the negative 7 pi over 6. Now, if you're not comfortable or want to, if you don't want to deal with the negative angle, you can always find a coterminal angle. So you can just add 2 pi if you need to. So if I add 2 pi, that's going to be the same as evaluating at 5 pi over 6. So my x component would give you 8 cosine 5 pi over 6. And then y would equal 8 sine 5 pi over 6. And then you can evaluate those to be whatever they are. Now for the next section. So now we're going to convert from rectangular to polar. So that's going to focus on this right section up here. So with rectangular to polar, what's happening here is we're going from x comma y, and we're going to transition into r comma theta. So we're looking for the distance from the pole, and we're looking from the angle at which that happens. Now, what you need to remember, your r value is just Pythagorean theorem. It's what we're doing over here. But the angle is where a lot of people tend to kind of get things a little confused. So with inverse tangent, what you have to remember is that we are restricted to negative pi over 2 to positive pi over 2. So if your angle so happens to fall in quadrant 2 or quadrant 3, you are going to have to add pi to that angle to kind of put it in the right quadrant. So just keep that in mind. So with that, what I like to do is on these problems, I like to actually identify the quadrant first. That way I know if I need to add pi or not. So if I have a negative 1 comma 1, well, that puts me in quadrant 2. So because I'm in quadrant 2, that means I need to add pi. And the reason is because that doesn't fall in the domain of inverse tangent. So because I fell into quadrant 2, I'm going to actually find the quadrant 4 value, and I'm going to add pi to move it to quadrant 2. So over here, my r value is going to be the square root of my x component squared plus my y component squared. So that's just going to give you square root of 2, which that can't simplify just, so you're just going to leave it alone. And then for your angle here, I'm going to have inverse tangent of my y value over my x value, so 1 over negative 1, which is going to be inverse tangent of negative 1. Now, on the unit circle, this is going to happen at negative pi over 4. So remember, we have to stay in the domain from negative pi over 2 to positive pi over 2. So that's going to happen at negative pi over 4. But because we're in quadrant 2, we do need to add pi to put it in quadrant 2. So I'm going to do negative pi over 4 and then add pi, which that's going to give me 3 pi over 4. So my actual coordinate here that I'm going to work with is going to be root 2, comma 3 pi over 4. So I'll give you guys a few minutes. I want you guys to pause here and actually try 6, 7, and 8. I know 8's a little tricky, but think about the direction of the original coordinate. That'll be my hint. So with 6, so we're going to go ahead and find our r value, which is the distance from the pole. So once again, we're going to do square root of those components squared. So I'm going to have 2 squared plus 2 root 3 all squared. Now what's going to happen is I'm going to do 2 squared, which is the first value, which is just going to give me 4. And then if it helps, what you can do is you can rewrite it as 2 squared and then root 3 squared. Since that value is going to both, you can quote unquote distribute. So this is going to simplify, or I'll rewrite it rather, as 4 plus 4 times 3. So over here, what's going to happen, you can actually square the 2, and then the radical with the 3, and then when you square it, are just going to simplify. So it's just going to go away. So I have 4 plus 4 times 3, so that's 4 plus 12, which is 16, square root of 16, which is just going to be 4. So now I need to find my angle. So my theta value, which I'm looking at inverse tangent of 2 root 3 over 2. Now, what I should have done at the very beginning is check the quadrant. So if I'm working with a positive comma a positive, that puts me in quadrant 1, which means I don't need to add anything, thankfully. So I don't have to worry about manipulating it. So you only have to add if your value falls in quadrant 2 or quadrant 3. So back over here, now we're going to simplify. So this is going to be inverse tangent of root 3. Now on the unit circle, when this happens, that's going to happen at pi over 3. So your coordinate here, we're going to look at 4 comma pi over 3. Ta-da! Number 7. So with number 7, so my r value, once again, you're going to square root the summation of both components squared. So a square root of 3 squared plus 0 squared, which is just going to give you a square root of 9, which is 3. And then for my angle, so I want inverse tangent of 0 over 3. Now that's just going to be inverse tangent of 0, which that happens at 0. So my coordinate here is 3 comma 0, which what's really annoying about this one, which I have a love-hate relationship with these, the question literally is the answer. So in rectangular form and in polar, it turns out to be the exact same thing, which is kind of neat, but also really annoying. I did all that work to get the same thing. But anyways, moving on. Number 8. So once again, same idea. We're going to do square root of both components squared. So 0 squared plus negative 4 all squared, which that's going to turn into the square root of 16, which is just going to turn into 4. And then for my angle, we're going to look at inverse tangent of negative 4 over 0, which is going to be undefined. So you have to ask yourself, where is tangent undefined? So tangent's going to be undefined at either, or not either, at pi over 2 and 3 pi over 2. But if you kind of ask yourself, look at the original quadrant, or coordinate. I want 0, negative 4. I know pi over 2 is going straight up, and I know 3 pi over 2 is going straight down. So because I'm looking at a value that's going straight down from the middle, that tells me that I'm going to want the 3 pi over 2. So I don't want the pi over 2. I want the 3 pi over 2. So this one is going to focus more on a visual aspect than it is more mathematical, I think. So your coordinate, we're looking at 4 comma 3 pi over 2. Now keep in mind, this is one way to write the angle. Depending on if it's multiple choice or the expectations, technically we could throw a little curveball at you, and we could also expect you to write negative pi over 2. These two angles would represent the same thing. So depending on the answer choices, if it's multiple choice, you just got to look out for whichever one we're looking for. If it was free response, honestly, I would accept either one. I would prefer the 3 pi over 2, but I would take the negative pi over 2. All right, now these are all values that if they are unit circle friendly, we can kind of evaluate them as is, but not every single value we give you is going to be unit circle friendly, which is kind of the booger. So over here, now we're going to give you rectangular coordinates of 3 comma negative 4. So I want to convert this to polar. So I need to do my r value. So this is going to be 3 squared plus negative 4 squared. So that's going to be the square root of 9 plus 16, which is going to be the square root of 25, which is going to be 5. And then I need to find my angle. So I'm going to do inverse tangent of negative 4 over 3. And, well, if you ask yourself, I can't do anything with that. That's not in the unit circle. I can't evaluate. So there's nothing I can really do. But if you look at your original angle, 3 negative 4 is going to be in quadrant 4. So I don't have to add anything, thankfully. I don't have to manipulate it because we're really just focusing on the direction it's going. So in this case, my exact value would be 5 comma inverse tangent of negative 4 thirds. So you would leave your angle in terms of this absolutely disgusting, abhorrent mess, which is gross, but also correct. So no touchy, just leave it. Now with number 10, this one's kind of gross, I'm not gonna lie. So negative 6 comma 9, that's gonna put us in quadrant 2. And because we're in quadrant 2, that means we're gonna have to add pi. So when I look at this value, so my r value, so we're gonna have negative 6 squared plus 9 squared. So that's gonna give me square root of 36 plus 81, which that's going to give me square root of 117, which I always want to think it's prime, but it's actually not prime. It can actually be rewritten. I'm going to say it's 3 root 13. Yes, 3 root 13. Hopefully I'm doing that in my head correctly. So that would be your r value, and then your theta value. So now we're going to look at inverse tangent of 9 over a negative 6, which is going to simplify to inverse tangent of negative 3 halves, which, once again, that's not in the unit circle. However, because we are in quadrant 2, I do need to add pi. So for your final coordinate down here for the exact form, we're actually going to have 3 root 13, comma, inverse tangent, negative 3 halves, plus pi. That would be your coordinate. And it's absolutely disgusting, but it is also correct. So speaking of disgusting, now we're going to do polar numbers and complex values. So complex numbers can be not rewritten, They can be written in the form of a plus bi, which I know you guys have seen this before, fingers crossed. And that is technically on what we call the Argand plane. Now the Argand plane is very similar to the Cartesian coordinate grid. It's just a different way of graphing. It's just graphing the complex values is all it does. So what you really need to understand and know is that on the Argand plane, the x-axis represents the real component, and then the y-axis is going to represent your complex or your imaginary component. This is really your big takeaway. So when we get to writing these values in terms of polar, we're going to expand on a plus bi. And that's because your a is going to correspond, I'll do this over here. So if I do a plus bi, this is going to correspond to your x component plus your y component, which has the imaginary value. And then in terms of polar, I know x is going to equate to cosine of theta plus the y component, which is going to correspond to sine of theta. And then that's going to be your imaginary component. But then because we're also talking about a distance from the pole, we also have to include your r value. And that r value is what's going to be multiplied in front of both your sine and cosine. So that's where these values here are going to come from. So the big form that we know is going to be this one right here. So what we did here is we just took the r value and we factored it out from both forms, or both terms. That way we just write it on the outside. So now we have r parentheses cosine theta plus I sine theta. And then this would be your complete imaginary polar form. And then we actually condense it because writing this over and over again gets real old real quick. So mathematicians have developed a way to kind of abbreviate it. So what we did is we took the r value, which is the distance from the pole, c for cosine, I for imaginary, s for sine, and then we took the theta value to represent your angle. So we have r, c, I, s, and then theta, which is where this comes from. So this is what we call your condensed form. So in your rectangular form and your polar form, what's going to be good to know, which I'm going to do a little divide here. In rectangular form, your answers are going to be in the form of a plus bi for complex values. But in polar form for complex, we're going to write them in the form of RCIS. So that's what your answers are going to look like depending on what form we're looking for. Now, I will say, for AP, we could write it either expanded or condensed. So you could expect to see either the full equation like this, whoops, or you can see the condensed. Either or are potential scenarios. So I'm going to start off on what I like to call as like level 1. So we have 1 plus 1i. So 1 plus 1i. So I'm going to write in that 1. Now, because both of these values are positive for your a and your b value, my a and my b value, which are going to correlate to my x and my y values. So if I have a positive x and y value, that means that we're going to be in quadrant 1. So what this information tells you is that if we are in quadrant 2 or 3, we are going to need to add pi. However, if we're in quadrant 4, because we don't like negative angles, in this case, you're going to need to add 2 pi. So now we're going to go ahead and plot on the argin plane and then work into converting. So because we're in quadrant 1, I'm only going to draw quadrant 1. If you want to draw the full plane, you're more than welcome to. So then I'm going to go ahead and draw our value that's going to be in quadrant 1, and I'm going to triangulate. So I want to clearly see the x and the y components. So when I do this, I know my x component, my horizontal component is just going to be 1, and then my vertical component is just going to be 1. So over here, I'm going to have 1 with a vertical component of 1i. So the I just tells you that's the imaginary, which means that that's your y value. That's all that really tells you. So what we need to find is going to be the r value, and we're going to need to find the angle that it forms. So over here, to find the r value, that's going to be the square root of each component squared. So 1 squared plus 1 squared, which is just going to give you the square root of 2. And then for my theta value, I need to do inverse tangent of my y over my x, so it's just going to be 1 over 1. You don't include the I. The I just tells you that it belongs to your vertical component. So you're only taking the coefficient, you're not taking the I. So this is going to be equal to inverse tangent of 1, which is going to happen at pi over 4. So what's going to happen is if I were to write it as a polar coordinate, it would be root 2 comma pi over 4. But remember, this is in the argin plane, and this is representing complex values. So really, we don't want the coordinate. What we're going to want is the complex form. So I'm going to write the r value and the theta value in our form, and then that is our answer. So I'm going to want root 2 CIS for cosine plus I sine theta, and then your theta value that we just found, which is pi over 4. So this is what we're looking for. So now we're going to look at the next one. So now we're going to look at converting from polar to rectangular in terms of complex. So we have 6 CIS 5 pi over 6. So I want to convert to x and y. So my x component is going to be r cosine of that angle, and then my y is going to be r sine of that angle. So when I plug in, so I'm going to have r, which in this case is 6, and then cosine of 5 pi over 6. And then down here, I'm going to have 6 times sine 5 pi over 6. So now you're going to evaluate. So 6 cosine 5 pi over 6, which is going to be negative root 3 over 2, which is going to simplify to give you negative 3 root 3. And then for the y component, so that's going to be 6 times sine of 5 pi over 6, which is going to be 1/2. So 6 times 1/2, which is going to give you 3. So if I write this in terms of rectangular complex values, I know that my real component, let's move this down a smidge so I can add in some notes. So I know my real component is going to be my x value. So this is going to be my a value. And then my complex value is going to correspond with my y value. So I'm going to add this value over here. I'm just going to tack on an I with it when I actually write it in. So over here, what's going to happen when I write the rectangular form is we're going to have 3 root 3. Or is it negative? Yes, it is. Negative 3 root 3, and then plus 3. And then because it's rectangular, with the b component, you just include the I. There we go. All right, and then last note I want to talk about is these last 4 problems. I'm not going to do these in the video, but I highly suggest that you do these 4 problems at some point, even just for extra practice. I would say these 2 problems up here are very kind of entry level, and then these 4 problems down here are where it gets a little bit higher level, so we start throwing in some more kind of crazy values at you. So definitely when you get a chance, do those values either to add on to the homework or to prep for the upcoming exam, but I believe in you. Bye-bye.